Hi, I'm Tyler Brand, and I'm currently a PhD student at the University of Utah. My dissertation research will be on logistics, AI, and spatial route optimization. A common theme or question that I think about on a frequent basis is how do things like pharmaceuticals, food, or common household items get delivered, and who actually figures out the most optimal route for these packages to be delivered, and what is the method to this madness? When it comes to delivery and route optimization, you can use exact methods, which typically use brute force to calculate all the possible routes, or you can use near optimal solutions but get done much quicker, and those are called heuristics. So in my dissertation research, I'm going to be studying 3 common optimization problems, and I'll talk a little bit about those here briefly, but they include the traveling salesman, vehicle routing problem, and the knapsack problem. The traveling salesman problem is essentially a starting point and say 10 locations and back to the starting point, and you have to calculate the shortest path between each of those. As you increase beyond, say, 10 locations, the computational complexity to be able to calculate the shortest route by brute force or exact method becomes computationally infeasible. So that is where things like heuristics come in, and I'll mention some of the ones that I'm studying for my research here in a little bit. But essentially, heuristics calculate near optimal solutions, but in a shorter amount of time. So keeping with the traveling salesman, what the vehicle routing problem is essentially multiple traveling salesmen. So you have a starting point and then multiple vehicles and then back to the starting point. So that optimization problem becomes even more complex. The third optimization problem that I'm going to be studying in conjunction with the vehicle routing problem is the knapsack problem. And basically the knapsack says, if you think about the knapsack or a backpack analogous to a delivery van or semi-truck trailer, we have items with different weights and levels of profitability or monetary values, and they need to be packed most efficiently for the particular delivery. So again, I'm going to be having a cold chain logistics theme throughout my research. So it's going to kind of start with supply chain logistics, food supply chain, and then spatial route optimization is kind of the 3 quadrants directing my research. And then ultimately I'm going to get into some AI as well. So the first model that I'm going to build will be overviewing 5 different heuristics, and these will include simulated annealing, ant colony optimization, taboo search, genetic algorithm, and particle swarm optimization. So I'm going to compare and contrast using real-time traffic and weather data, how these different heuristics perform on a small vehicle routing problem. And then I'm eventually, for the rest of my dissertation chapters, going to expand on this model and eventually get into reinforcement learning or machine learning to learn from this first model and try to make the routes more efficient. So I'll eventually be getting into AI and machine learning. I'm really excited to get into this research. The route optimization piece is fascinating to me, and a lot of people think that it's something that every single company has solved, whether it's UPS or Amazon, but we can always make things more efficient and find better solutions, since it's not something that can be exactly solved at this stage in the game. Once we get to quantum computing, we may have a situation where things can be solved much quicker and in more of an exact manner, but we're still a ways from that. Hopefully this video gave you a little bit of background on my research and what direction I'm headed, and I'm excited to get into it. Thank you.